Good morning. Try it again. Good morning. All right. I'm Pat Damer. I'm the Acting Director of the Office of Science, and on behalf of the Department of Energy and the Office of Science, welcome to the finals of the 2014 National Science Bowl. Yes. After several days of activities and competitions at the 4-H Center, we're now down to the final two teams for the middle school competition and the high school competition. Welcome to all of the teams. Welcome to the coaches, the parents, the friends, distinguished visitors, and guests. We're going to have a special guest for you later this morning after the final competitions. That's Secretary of Energy Ernest Moniz to help present the awards. I want to extend special thanks to Jan. Where's Jan? There's Jan. Jan Tyler. Yes. And the legion of volunteers that Jan conscripts. We're very pleased this morning that we have David Zarin once again to act as Master of Ceremonies of the National Science Bowl Finals. David, over the past 25 years, has written, produced, and starred in, hosted in a large number of award-winning science and public affairs programs. He's well known for this. He's the host of It's Academic, broadcast out of Baltimore. He is also the Senior Television Instructional Specialist for the Prince George's County, Maryland, Public Schools Office of Television Resources, and so as not to fall idle during the weekends, he is also the meteorologist forecasting the weather for News Channel 8 and WJLA ABC 7 News. We are extremely pleased to have David with us today. Please join me in welcoming him.
Thank you, Pat, and good morning. And it is certainly nice to be back for my 15th year here at the National Science Bowl. And Pat mentioned very nicely that I am a meteorologist. I'm happy to admit that on a morning like this. When the sun is out, you guys have had a great weekend. And I have to tell you, it's really nice to hear applause for a change. You take your cues well. All this winter, those of you that lived anywhere on the East Coast know that we had the worst winter ever. It just never stopped snowing. And the public turned on us. And we tried as best we could. We tried to pacify them with, it's the polar vortex. They weren't buying that. We tried the North Atlantic Oscillation. We said the jet stream was sagging. We were blamed for all of the bad weather. But thanks to some daughters and their friends and a lot of little girls who visited the station, we finally came up with our scapegoat. They said, Dave, we've all seen the movie Frozen. It was Elsa who did it, the Ice Queen. We thought that was a pretty good explanation, so we adopted Let It Go as our theme song. We were all singing Frozen Fractals all week and all winter, and like Elsa, the cold never bothered me anyway. Welcome to the finale of the 24th Annual Department of Energy National Science Bowl. You know, this all started back in 1991. That was before any of you were born. I'm talking to the students, of course. Back in 1991, Pluto was still a planet. Fishing was done with a pole. Candy Crush was a treat in the bottom of our Halloween bag. And since photos were taken with film and had to be developed, selfies were out of the question. You know, since 1991, over 500 high schools and middle schools and over 240,000 students have competed right here in the nation's capital. Today, there are 580 of you here, representing 68 high schools and 48 middle schools, and we are especially happy to welcome the 21 new high schools and the 21 new middle schools. Could you guys stand so we can see you? and recognize you. There they are, folks, the new kids on the block. Good to have you here. At the other end of the spectrum, we have two schools here this morning who have been with us most of our existence. 17 of our 24 years, two schools. Mira Loma High School. Where is Mira Loma? Mira Loma is our defending champion, three-time national champion, and their coach, Mr. Jim Hill over there, has been with us for 15 years. Mr. Smith, always good to have you here. Thank you, and good luck today. The other school that's been here for 17 years, the Thomas Jefferson Science and Tech School from nearby Alexandria. Thomas Jefferson, where are you folks today? Right there in the center. And their longtime coach, Sharon Webb, is with us here today as well and works with the bowl, and she's just a phenomenal educator. Thomas Jefferson, incidentally, has won 4 national championships, and that record still stands. As far as the middle schools, we started this competition back in 2002, and 2 of the schools here today have been with us for almost all of our 12 years. 9 years with Van Antwerp Middle School from Niskayuna, New York, and Lux Middle School from Nebraska, here 9 and 8 years respectively. Van Antwerp and Lux, could you stand so we can recognize you? They're way in the back there. Thank you so much for being here all these years, and congratulations. How many of you, like Emily Gay of Clarence Middle School up in New York, are here in Washington, D.C. for the very first time? Very first time. A lot of hands out there. You know, if it's your first trip here, it's no different than for those of us that have lived here most of our lives. There's a thrill about being in Washington, and I hope you felt that. Sitting in this magnificent hall that looks like the Parthenon, if you're walking on that great green swath of the mall, if you go atop the Kennedy Center and you see the monuments and the Potomac River, there's just a grandeur about Washington that takes your breath away. And we hope you've felt that here this weekend, and we hope you come back many times. I also hope you've made a lot of new friends while you're here. Some of you have been here year after year. I know you go on Facebook. I know you text, because you're making friends here that you're going to run across in ways you don't imagine as you go through your life. There's a certain kind of camaraderie here that you've felt, and you take it back with you, and it's something that will never leave you. You're having a souvenir experience. You'll always think back to this time, and hopefully you'll come back like our alums and participate and volunteer with us. The fact that you're here tonight and this morning in such a huge mass, I hope you don't feel anonymous. If you're sitting out there thinking, you know, I'm just one in many, you're not. All this weekend, you have been representing your hometowns, and no matter where you placed in this competition, you are hometown heroes, and I hope you know that. Give yourselves a hand. You are hometown heroes. Think about it. The federal government flew you here, except for the local teams that came by subway. They flew you here, they fed you, they housed you, all because of your academic success and your hard work. That rarely happens in this life. Very few people in this country will ever have this kind of recognition, and I hope you appreciate your specialness and the honor that you've had. And speaking of hometown heroes, a student who enjoyed this experience as much as you are right now was Austin Hudson Lepore. You might have read your program and read that, tragically, Austin, who was here for 4 years, from 2005 to 2009, representing Albuquerque Academy out of New Mexico on the middle and high school teams, he lost his life last summer. It's a terrible blow to all of us, because we are family. Like many of you, Austin couldn't get enough of this experience. He loved Science Bowl. His parents say that he used to wear his Science Bowl t-shirt even to bed out on the street. It was his badge of honor that he had been through this experience. And he loved it because he got to be among people that were kin, people who loved science as much as he did. Austin's parents are here with us today, and we grieve with them. And we're very sorry for their loss. But we hope that just being in this place where their son had so much enjoyment, that it will help sustain them and maybe even bring a smile or two. Could we ask Mr. and Mrs. Austin Lepore, Hudson Lepore, to stand, please, because they're with us today, right here in the front. And we hope during the breaks here and at lunch and maybe before you get on your buses to go out to the airport that you have a chance to greet them and tell them how much this experience means and give them a hug. You might feel a little uncomfortable, but take it from personal experience. It will mean a lot to them. Thank you very much for being here today. I also want to echo what Pat said about Jan Tyler, General Jan Tyler, who organizes this thing with military precision and comes through every year with a combination of a general's toughness and a mother's compassion. And I hope all of you know that this thing doesn't just happen. As you're leaving today, Jan and her troops will already start organizing next year's Science Bowl. It takes that much preparation. Let's give Jan another great hand and her team. Thank you, Jan. And before we start the competition, my favorite part. I've spent the past couple weeks reading your bios. I love them. So many of you, you're not only smart kids, you are good kids. Because back in your homes, you're generous, you have big hearts, you help out your families, you help out your communities. You are making significant differences where you live. You're not just bright students, you're pillars of your community. You also have some unusual likes and dislikes. Some of you have great senses of humor. Some of you could have taken Stephen Colbert's place on the Letterman show. Let me tell you about some of if maybe you've not read these. For instance, there are students here who are being completely honest about why they came. Brian Lee of Walton High School in Marietta, Georgia. Brian, if you're out there, he says, yeah, the competition's great, the food's good, but the best part of Science Bowl is the free Frisbee. He's easy to satisfy. Easy. Free. That costs us nothing. Suleiman Ahmed of Hopkins Junior High in California plans on being legendary in his own time and beyond because he hopes to be the final answer in the 3001 National Science Bowl competition. He'll outlast Einstein. Suleiman, cold fusion might do it for you. And Jake Klein of American Heritage School in Plantation, Florida, I love this. He has been here enough times that he reminisces about when computer science was a Science Bowl category. Now that it's gone, he says he weeps softly into his pillow at night. I've got that image in my head. Yeah. Juan Lee of Lexington High School in Massachusetts tells us that he can't wait to meet his favorite scientist, Ernie Moniz. Ernie? The Secretary of Energy? Dr. Moniz? Ernie. All right, on good terms with the guy. Always good to suck up to the boss, Juan. Always good. A lot of you like to share your hobbies. In some cases, it was a little too much information. Like sweet-sounding Nina Vander Zanden of Ames, Iowa, Ames High School in Iowa. Seems a very nice girl. She tells us that she belongs to the speech club and the swim team, and she enjoys crocheting, knitting, and knife throwing and whip cracking. Whoa! You don't mess with Nina. No way. Nabir Sarma of Eden Prairie Middle School tells us that he is quite the musician. He plays the clarinet, the piano, the guitar, the bass, the cello, and the violin in the Greater Twin Cities Youth Symphony. Nabir, you are the Greater Twin Cities Youth Symphony. And my last story was my favorite. Andrew Moten of Tokay High School in Lodi, California. Who knew that Cupid's arrows were flying here? He says that during science ball practice, he met his girlfriend 3 years ago, and they're still together. They can be found, in his words, studying entomology together on warm Friday nights. Use your imagination, folks. We have some winners to announce before we start our competition here. On Friday, all the high school teams participated in the Division Team Challenge Science activity, and it was about looking at transformation of energy with toy trains. You were measuring the thickness of toilet paper. You were doing math modeling and cratering sugar bowls. There were 8 divisions. Each of these teams will receive $500 for science supplies for their schools. I'd like for these teams to stand as I read your names. They are all outstanding scholars. In the Arrhenius Division, Mira Loma High School, Sacramento, California, $500. The Brommery Division's winner is Ames High School, Ames, Iowa. That's Nina Vanderzinden with the knives, $500. The Curie Division's winner is Fairview High School of Boulder, Colorado. Fairview High, over there. Our next winner, familiar to us here on Science Bowl, has been coming for years in the Darwin Division, University High School, Irvine, California. Big smiles over there. In the Einstein Division, our $500 winner is the North Carolina School of Science and Mathematics in Durham. Right there. Good job. The Fermi Division's winner, State College Area High School in State College, Pennsylvania. My alma mater, Penn State. Nice to see you guys. Congratulations. In the Galileo Division, $500 to Los Alamos High School, Los Alamos, New Mexico. And what a splash this team has made. Not only have they won a Division Team Challenge, they are in the finals, and it is their first time ever at the Science Bowl in the Hypatia Division. Westview High School, Portland, Oregon. There they are. We mentioned alumni earlier. For the past 14 years, National Science Bowl alumni have been invited to come here to the National Science Bowl and participate as volunteers. You've seen them around. They assist with doing so many different things. They serve as competition officials. And most importantly, they serve as role models. We hope you also will consider coming back and joining us. This year, I have 23 alumni here in attendance. One of them will be moderating this morning. Another is the lead science judge. 2 will be stage rules judges, and several others will serve as judges throughout the room. Could we have all 23 of our alumni stand and be recognized? Thank you all for being here today. Familiar faces to us. And now the main event, which you've all been waiting for. Who will win? On to the competition. Again, we started 48 middle schools, 68 high schools. We are down to the final 2 middle school teams. They are Greater Boston Math and Science Team from Andover, Massachusetts. They are undefeated in double elimination, and they will be playing against the J-Droids Science Club from Wayne, New Jersey. They have 1 loss in double elimination. In the high school competition, we have Mira Loma High School from Sacramento, California, undefeated in double elimination, and Westview High School from Portland, Oregon, with 1 loss. We wish all of the teams the best of luck this morning. I'm now going to turn this microphone over to our two moderators. Adam Matthews. Dr. Matthews has been with us for 12 years, and first time here at the moderating table, Phelim McGowan. Gentlemen, it's up to you.
Thank you very much, Dave. All right, thank you very much. Welcome to the finals of the 2014 High School National Science Bowl competition. At this time, I'd like to welcome our two competing teams to the stage. Team A, competing from Sacramento, California, Mira Loma High School. And Team B, coming to us from Portland, Oregon, emerging from the challengers bracket, Westview High School. All right, thank you, Mira Loma. Thank you, Westview. As you get settled, I just want to make note that we've switched moderators. So in this round, I will be reading to you, I'll be moderating, and recognition will be done by the fine gentleman to my left. At this time, we like to test the buzzers, make sure that all the buzzers are working, that the lights are going on, and have you wait for verbal recognition. Let's please start at the right side of the stage. We'll work our way across. Please buzz in. Tell us your name, your year in school, and what you major in college.
B3.
My name is Abhijit Mudigonda. I'm a junior at Westview, and I plan to major in chemistry or chemical engineering when I enter college.
Thank you.
B2.
My name is Vincent. I am a senior, and I want to major in math and computer science.
Thank you.
B Captain.
I'm David. I'm a senior, and I want to major in either physics or astrophysics.
Thank you.
B1.
My name's Eddie. I'm a senior, and I would like to major in computer science.
Excellent.
A1.
My name is Arvind Sundararajan. I'm a junior at Mira Loma High School. I would like to attend MIT, where I would like to study astrophysics.
A Captain.
My name is Daniel Shen. I'm a junior at Mira Loma, and I would like to attend Caltech and major in engineering.
A2.
My name is Jack Garev. I'm a sophomore at Mira Loma. I would like to attend MIT and major in computer science and math.
Thank you.
A3.
My name is Matt Kempster. I am a senior at Mira Loma, and I will be attending Caltech in the fall, where I will possibly be majoring in biology or computer science.
Congratulations. All right, it appears that all the buzzers are working. All of you are speaking nicely into the microphone. Again, please wait for verbal recognition before you give your answer. Do you have any questions before we get started? You both ready to go? Okay. Without further ado, let's begin. This is the finals of the National Science Bowl High School Finals. Toss-up question number 1, chemistry, short answer. What general type of reactive intermediate, which can be formed from the photolysis of an azide, consists of a hypovalent electrophilic nitrogen and can be thought of as an analog of a carbene?
A Captain.
Diazonium.
That is incorrect.
B3.
Nitrine.
Nitrine is correct. And your bonus question is visual, in chemistry, multiple choice. The reaction in this image was probed via kinetic isotope effects and found to show a kinetic isotope effect of approximately 25. Which of the following is true regarding the reaction? W, the deprotonation step, is not the rate determining step. X, the deprotonation step likely involves quantum tunneling. Y, the deprotonation step demonstrates an inverse KIE. Z, the deprotonation involves a secondary isotope effect.
Which is not true?
Yeah, it's not.
I believe it's W.
W? You think so?
So I believe W. It should be the right one. Okay. Wait, the deprotonation of what? What was Y?
Why was
Inverse K.
5 seconds.
W.
I'm sorry, it was actually X, quantum tunneling. Toss-up number 2 is in physics, multiple choice. An alien spacecraft is traveling directly away from a stationary observer at 99% of the speed of light. Taking relativistic effects into account, how does the observed width of this ship, perpendicular to its direction, compare to that of an identical ship at rest in the same position? W, the width will be contracted. X, the width will be elongated. Y, the width will be the same. Interrupt.
A2.
Why?
Is correct. And your bonus question in physics is short answer. In a canonical ensemble, identify all of the following 4 quantities of the system that are held constant. 1, energy. 2, number of particles. 3, temperature. 4, volume.
Yeah, I agree. Yeah. So number of particles. Energy? I think so. All right. Temperature. Okay, no, if you hold energy. All right, volume. All right, let's go 1, 2, 3. All right.
5 seconds.
All but 4.
Sorry, it's actually all but 1. Toss-up number 3, energy, multiple choice. Which of the following statements is not true regarding virtual particles? W, virtual particles can possess negative kinetic energy. X, the strong nuclear force between quarks involves the exchange of virtual pions. Y, interrupt.
A1.
X.
Is correct. And your bonus question is visual, in energy, short answer. Depicted in the image is an anabolic process performed by plants and bacteria. Answer the following 2 questions regarding the image. 1, what is the name of this biochemical cycle which converts acetyl-CoA to succinate? 2, this cycle is generally used by plants to produce a particular structurally important molecule from fatty acids. What molecule do they produce via this cycle?
All right. 1 is the glyoxylate cycle.
Glyoxylate. And what is 2?
I think 2 is, wait, what is produced?
Yeah, what is produced? Fatty acid from fatty acid.
I think it's oxaloacetate because I agree. Are you sure it's not malate? Oxaloacetate is in the figure.
All right. Wait, oxaloacetate is in the figure.
No, yeah, it's not shown.
All right.
Because I want you to know.
1 is glyoxylate.
Glyoxylate cycle.
1 is glyoxylate cycle, and 2 is oxaloacetate.
Sorry, 1 is glyoxylate, but 2 is glucose. Toss-up number 4 is in Earth and space, short answer. What is a name for a no tide point in the ocean that occurs at only about a dozen places on Earth?
A1.
Dead point.
That is incorrect.
B3.
Lagrange point.
Sorry, it's actually an amphidromic point. Toss-up number 5 is in biology, multiple choice. Which of the following correctly describes the best method by which a protein containing 6 adjacent histidine residues could be purified from cell lysate? W, ammonium sulfate precipitation. X, ultracentrifugation. Y, affinity interrupt.
B3.
Y.
Is correct. And your bonus question, biology, is visual, short answer. Displayed in the image is the histopathology of the gastrocnemius muscle from a patient of a recessive X-linked disorder. The patient also shows signs of muscle weakness, particularly in skeletal muscles, and symptoms originally appeared around age 6. What specific disorder does that patient likely have?
Duchenne's muscular dystrophy, I believe. Duchenne's muscular dystrophy.
Duchenne's muscular dystrophy.
Is correct. Toss-up number 6 is in energy, short answer. Iceland's unique geography allows it to produce its electricity almost exclusively from interrupt.
A1.
Geothermal.
That is incorrect. I'll repeat for Team B. Toss-up, energy, short answer. Iceland's unique geography allows it to produce its electricity almost exclusively from renewable sources. Volcanoes, hot springs, glacial rivers, and waterfalls are used to produce nearly all of Iceland's electricity from what 2 methods?
B, Captain.
Geothermal and hydrotherm.
Sorry, it's incorrect. It's geothermal and hydroelectric. Toss-up 7 is in math, multiple choice. Which of the following descriptions of an n by n matrix is not equivalent to the others? W, invertible. X, singular. Y, determinant interrupt.
A2.
X.
Is incorrect. I'll repeat for Team B. Toss-up in math, multiple choice. Which of the following descriptions of an n by n matrix is not equivalent to the others? W invertible, X singular, Y determinant equals 0, Z rank is less than n.
B2.
W.
Is correct. And your math bonus question is visual, short answer. Sudoku is played on a 9 by 9 grid as shown in the figure. The 9 non-zero digits are placed in the squares in such a way that no digit appears twice in any row, column, or boldly outlined 3 by 3 square. Assume that the board's orientation cannot be changed. The number of different ways the 9 fours could be placed on the board, one of which is shown, can be expressed in the form a to the n, where a and n are integers and a is as small as possible. What is n?
9, so it's probably 18. I would guess 2, right? A to the n. Oh, the number of ways. Never mind.
Okay. Go with that. 18.
Sorry, it was actually 6. Toss-up number 8 is in Earth and space, multiple choice. According to the Kelvin equation, vapor pressure of a small water droplet in the atmosphere is increased by which of the following? W, decreasing relative temperature, X, decreasing radius of curvature, Y, increasing optical depth, Z, decreasing optical depth.
A, Captain.
X.
Is correct. And your Earth and space bonus question is visual, short answer. Answer the following 2 questions regarding the image. 1, what celestial body is pictured? 2, what surface feature is conspicuously absent from this object, suggesting that its surface is continually reformed?
Craters.
1 is Io.
And 2 is impact craters. Yeah. 1 is Io, and 2 is impact craters.
That is correct. Toss-up number 9 is for both teams, physics, and it is multiple choice. Consider a simple circuit consisting only of a capacitor, a switch, and a resistor. The switch is initially open, and the charge on each of the capacitor plates is plus or minus Q. After the switch is closed, which of the following best describes how the magnitude of the charge on each plate decreases with time? W, instantaneously, X, linearly, Y, could interrupt?
A2.
Z.
Is correct, exponentially. And your bonus question in physics is visual, short answer. In this picture is a telescope. Indicate all of the following statements that are true of this object. 1, it is an interferometer. 2, it can detect infrared and visible EM sources. 3, it can detect periodic emissions from the Vela pulsar.
Yeah. Okay, this is a radio, so it can't detect visible. Yeah. How would it detect visible? It has no mirrors. All right, so 1 and 3.
Is correct. Toss-up 10 is in biology, short answer. What neurological disease, occurring when spores of Clostridium invade a poorly oxygenated wound, causes blockage of inhibitory neurotransmitter release from interneurons to motor neurons, resulting in high-frequency action potential firing?
A3.
Tetany.
That is correct. Bonus question, biology, multiple choice. Which of the following would you not expect to observe when experimenting on smooth muscle located in the GI tract? W, stimulating parasympathetic nerves would cause the muscle to contract. X, blocking voltage-sensitive sodium channels would prevent contraction. Y, applying a drug that blocks beta receptors would prevent contraction. Z, blocking acetylcholine receptors would prevent contraction.
Okay, 3's wrong.
All right, so why? I mean, why? Yeah, which is not true.
Wait, which is not true?
Yeah. Yeah.
Why?
Why?
That is correct. Toss-up 11 is in chemistry, multiple choice. Which of the following statements concerning the radical halogenation of alkanes is false? W, CH abstraction is faster for tertiary carbons than for primary and secondary carbons. X, chlorination is more selective for tertiary carbons than bromination. Y, the rate law for the process is often of fractional order in the halogen. Interrupt.
B3.
Z.
Is incorrect. I'll repeat for Team A, toss-up in chemistry, multiple choice. Which of the following statements concerning the radical halogenation of alkanes is false? W, CH abstraction is faster for tertiary carbons than for primary and secondary carbons. X, chlorination is more selective for tertiary carbons than bromination. Y, the rate law for the process is often of fractional order in the halogen. Z, the reaction of two alkane radicals is a possible termination step.
A, Captain.
W.
Sorry, it was actually X. Toss-up number 12, physics, short answer. What is the name of the process in which a nucleus emits or absorbs gamma rays without loss of energy to a nuclear recoil?
A2.
Spontaneous emission.
That is not correct.
B3.
Auger effect.
Sorry, it's actually the Mossbauer effect. Question 13, toss-up chemistry, multiple choice. Assume that a hydroboration-oxidation reaction is performed on an asymmetric alkene. Which of the following statements is false? W, the major product of the reaction, is an alcohol. X, the addition of the borane to the alkene is syn with cis stereochemistry. Y, the reaction obeys Markovnikov. Interrupt.
B3.
Y.
Is correct. And your bonus question in chemistry is visual, short answer. NO2 is a toxic gas and a prominent component of smog. It is in equilibrium with its dimer N2O4. One of these gases is brown, while the other is colorless. Answer the following two questions regarding the picture. 1. On the Arrhenius plot pictured, which labeled line describes the reverse reaction? 2. Smog is browner on hot days than it is on cold days. Assuming that the forward reaction depicted is bimolecular and the reverse reaction is unimolecular, which gas is the brown gas?
Brown gas is and what was the first question?
Which one of the lines is the reverse reaction?
And which one happens more easily? No, which one happens more
I
easily?
would say B is a reverse because it's at high temperatures. Or sorry, A is a reverse because at high temperatures.
A and NO2.
A and NO2 seems.
5 seconds.
A and NO2.
That is correct. And that is the half. Score at the half is Miraloma 54, Westview 44. We'll now take a 5-minute break. All right, thank you very much. Do we have any substitutions at the half? Either team? All right. We've gone through 13 questions in the first half. The score is as shown there. We have a 10-point game right now. If you guys are ready to go, we'll pick up with question number 14. It's a toss-up question in math, short answer. Convert 1, 2, 2, 1 in base 3 to base 9.
A2.
5, 7.
I'm sorry, that was stalling.
B2.
5, 7.
Is correct. Your bonus question in math is short answer. Two players are playing a turn-based game where each player has a 2/3 chance of winning on a particular turn. If player A gets the first turn, player B gets turns 2 and 3. Player A gets turn 4, and player B gets turns 5 and 6, and so on. What is the probability of player A winning the game?
Five seconds.
3/4.
Sorry, it's actually 9/13. Toss-up 15 is in biology, multiple choice. Which of the following is not a function of folic acid in the human body? W, 1 carbon transfers in the synthesis of purines. X, 1 carbon transfers in the synthesis of methionine. Y, 1 carbon transfers in the synthesis of glutamate. Z, 1 carbon transfers in the synthesis of fatty acids.
B3.
Y.
I'm sorry, that's incorrect.
A1.
Z.
Is correct. And your bonus question in biology is visual, short answer. Displayed in the image are 4 flowers which are pollinated via different means. Pair the following 4 modes of pollination with the flower that uses that mode of pollination. 1, moths. 2, birds. 3, bees. 4, wind.
All right, the red one is bees.
All right, so B is 3, C is wind. What is D?
What is what?
What is D?
One is moths.
Wait, one, no, no. The red one is moths. All right, what is A?
Wait, the red one is
You said the
B.
red one. Oh, you said the red one was B. Okay, sorry.
Go with
Which one's moths?
A.
Right, A. All right.
So with A, D, B, C?
A, D, B, C.
A is 1, B is 3, C is 4, and D is 2.
Sorry, actually, A is 3, B is 2, C is 4, and D is 1. Toss-up 16 is an Earth and space multiple choice. What is the relationship between the spectra of short gamma ray bursts to long gamma ray bursts? W, short gamma ray bursts have more spectral lines than long gamma ray bursts. X, short gamma ray bursts have softer spectra than long gamma ray bursts. Y, the spectra of short gamma ray bursts is the same as those of long gamma ray bursts. Z, short gamma ray bursts have harder spectra. Interrupt.
A, Captain.
Z.
Is correct. And your bonus question is in Earth and space. Visual, short answer. Shown here is the bullet cluster, which consists of 2 galaxy clusters that have recently collided. The blue region is a map of the dark matter, and the red region is a map of the ordinary gaseous matter of the cluster. Answer the following 3 questions about this image. Answer the following 2 questions about this image. 1. What phenomenon was observed to derive the dark matter map? 2. What wavelength of light was observed to derive the gaseous matter map?
All right, so 1 is gravitational lensing.
Yeah.
Yeah, okay. 2.
Wavelength?
Of
They want,
light
like, fast, like,
to-
line bomber, etc.
No, I think they just want like radio. Okay, so let's go with radio.
Radio.
Wait, no. They said
Because it's gas. Wait. Huh?
They wouldn't.
Wavelength.
They wouldn't want radio.
Wavelength?
Wavelength.
No, I think.
I think Daniel's right.
All right.
It's a region
All
and
right, but, okay, so 1 is.
go with radio.
1 is gravitational lensing and 2 is radio.
Sorry, it's gravitational lensing and X-ray. Toss-up 17 is for both teams. It's in math, short answer. What is the second smallest positive integer that has exactly 5 positive divisors?
A2.
81.
Is correct. And your bonus question is in math, short answer. The proper divisors of a positive integer are all of its positive divisors except for the number itself. How many positive integers have exactly 3 proper divisors, each of which is less than 10?
Okay, so it has to be less than, oh wait, no, it doesn't have to be less than 10. Okay, so it's either a prime cubed, or prime cubed, or it's a prime times another prime, so it's 8, 27.
How many are
and then
there?
you have 6, 10.
5 seconds.
6.
6.
Sorry, it was actually 8. Toss-up 18 is in chemistry, short answer. What equation in the physical chemistry of aqueous equilibria gives activity coefficients for dilute solutions of salts as a function of ionic strength?
B3.
Hammett equation.
Sorry, that is incorrect.
A1.
Van 't Hoff's isochore.
Sorry, it's actually the Debye-Huckel equation. The next question is number 19. It's a toss-up in energy, short answer. What aerodynamic law calculates the maximum power that can be extracted from the wind? Interrupt.
A1.
Betz' law.
Is correct. And your bonus question in energy is visual, short answer. Depicted in the image is a special type of electric cell. Answer the following 3 questions regarding the image. 1. What particle is represented by the large arrow labeled A? 2. What physical phenomenon is depicted by arrow B? 3. What particle is represented by the dot labeled C?
All right, what is this? I think it might be the photoelectric effect. So let's see. A is a photon.
Yeah, okay.
B
would be
is
phenomena,
so it's photoelectric.
electron,
Photoelectric.
and then C would be electron.
Yeah. All right. 1 is a photon, 2 is the photoelectric effect, and 3 is an electron.
Sorry, that's incorrect. 1 is a photon, 3 is an electron, but 2 is a reflection. Toss-up number 20, biology, multiple choice. Which of the following is true regarding the process of glycogenesis? W, the first step of glycogenesis is the conversion of glucose 1-phosphate to glucose 6-phosphate. X, glycogenesis is stimulated by epinephrine. Y, glycogenesis has a UDP gluco-interrupt.
A3.
Y.
Is correct. And your bonus question in biology is short answer. By number, identify all of the following 4 physiological conditions a patient with hypoparathyroidism would most likely present. 1, increased blood phosphate concentrations. 2, increased blood calcium levels. 3, weaker, less mineralized bones. 4, spastic contractions of the skeletal muscles and tetany.
Hypoparathyroidism. That means there's underproduction of hyperthyroid hormone, which stimulates desorption of.
So then therefore 2 and 3. Oh wait, so no, therefore not only 1. All right,
So I think
5 seconds.
3 and 4.
Sorry, it was 1 and 4. Toss up for both teams, Earth and space, multiple choice. What type of atmospheric inversion occurs when warm air moves over cold topographic features? W, unstable inversion. X, hydroscopic inversion. Y, advective interrupt.
A1.
Y.
Is correct. And your bonus in Earth and space is visual. Short answer. Identify the feature shown that would form when a Pahoehoe lava flow around a hill creates an island of land completely surrounded by lava.
Like Nue Ardent.
No. Is it like an insult?
Like Arvin, could that be it?
Huh? It's not Nuit. No.
Inselberg.
It's a good guess. It's a kipuka. Toss-up 22 is in math, multiple choice. Given a figure and its image under a rotation, which of the following can be used to locate the center of the rotation? W, 2 parallel lines. X, 2 perpendicular bisectors. Y, 2 angle bisectors. W, Z, 2 circles.
A2.
X.
Is correct. And your bonus question in math is visual, short answer. The image shows a 3-dimensional shape that looks the same from the reverse side. It is formed by beginning with a cube, identifying the front and back faces, and then drilling a square hole through them. For this shape, what is its number of vertices, faces, and edges, respectively?
Okay, so you have 4. You drill a hole, so you have 4. Wait, what's happening here?
1, 2, 3, 4.
I don't know what
Four,
it is.
so you have, like,
a cube. So you have 6, and then you have
so
edges. 10
10
faces.
10 faces.
You have plus 8, so you have 16 vertices. V minus E plus F equals 2. So you have 24 edges.
Right.
So
16. All right.
16 vertices, 10 faces, and 24 edges.
Sorry, it's actually 16 vertices, 16 faces, and 32 edges. Toss-up 23 is in physics, short answer. Indicate all of the following statements that are true regarding fermions. 1, a photon behaves as a fermion. 1, a proton behaves as a fermion. 2, fermions obey the Bose-Einstein statistics. 3, composite fermions are made of an interrupt.
A1.
All of them.
Is incorrect. I'll repeat for Team B. Toss-up physics, short answer. Indicate all of the following statements that are true regarding fermions. 1, a proton behaves as a fermion. 2, fermions obey the Bose-Einstein statistics. 3, composite fermions are made of an even number of quarks or leptons.
B1.
1 and 3.
Sorry, it's just number 1. Toss-up 24 is in chemistry, multiple choice. What reagent affects the transformation of ketones to esters in the Baeyer-Villiger reaction and the interrupt?
B3.
Metachloroperoxybenzoic acid.
Sorry, that's incorrect. I'll repeat for Team A. Toss-up chemistry, multiple choice. What reagent affects the transformation of ketones to esters in the Baeyer-Villiger reaction and the transformation of alkenes into epoxides through a concerted butterfly mechanism in the Prelaziev reaction? W, amide. X, acyl halide. Y, Grignard reagent. Z, peroxy acid.
A, Captain.
Z.
Is correct. And your bonus question in chemistry is visual, short answer. Depicted in the image is the Wiegand 1,3 dipolar cycloaddition, which has recently become popularized by K. Barry Sharpless as click chemistry. Answer the following 2 questions regarding the image. 1, which 2 functional groups in molecules 1 and 2 are participating in this reaction? 2, is a triazyl ring formed by this reaction aromatic, anti-aromatic, or neither?
It's anti. So you have alkyne and diazonium. Oh wait, no, sorry, alkyne and azide. All right. 1 is alkyne and azide, and 2 is anti-aromatic.
1 is alkyne and azide, but 2 is aromatic. And that is the end of the match. Final score is Mira Loma 90, Westview 52. Please join me in congratulating Mira Loma, our 2014 High School National Science Bowl champions. Thank you very much. At this time, we'll take a 15-minute break while we set up for the award ceremony.